Hello again, and welcome back to the Matrix, I guess you might call it. There's so many things to mention that I don't really know exactly where to start. So I'm going to pause for a second and look at my list. Okay, well, first up, I had a belief anyway that it must be possible somehow to elevate the privilege level of a process, because it appears as though I've seen that happen. I think I've seen that happen, like with that PS exec and so on. And I had remembered in the past something like having a function with this name, add privilege. But now I don't believe that's possible anymore. Nor was it possible then. Now, where to begin? This is that tokens thing from before. Still runs, I hope. Now, why is that? Oh, I know why it's going there. Oh. Okay, now, here's the privilege set of that program I just ran. Now, these can be enabled, and that is the complete and total list and unchangeable list that it is assigned to whatever the data structure is that is associated with that process. And I think that's the end of that story. Now I thought, because I was looking through the help, and it mentioned a lot of times it would mention these functions that all start with the letters LSA. Now there's no real overview of LSA. And the help is really, if you look at it, it's really looks more like it's geared towards somebody who would be implementing LSA. LSA is Local Security Authority, and it's a package. It's something called a package which implements something like another layer between the security, the base security functions, like MFC does, and simplifies some of the function calling. So I don't think this LSA really adds anything, except it can organize the information in a slightly better way and tell you a bit more. Like for instance, just reading this. All the LSA functions mentioned above support both account rights and privileged constants. Now, privileged constants are like that SE, the debug name, and so on. Unlike privileges, however, rights are not supported by, these are the functions the operating system provides, this or this. Now, the function that I was calling for that token thing was using this, and it will obtain information on rights if groups and privileges are specified as the value of the information class parameter. And not privileges. So if you just take groups and don't specify privileges, then you will obtain enough information, at least, to decide whether or not a logon name has one of these rights. Now, these constants are made up by the local system authority. Okay. Now, these are the standard privilege names, okay, that you find in the header files of winnt.h or win security.h or whatever header file they're in. They don't tell you, but it says somewhere. And these are all string values. I have here they are in winnt.h. Okay. Now there are no rights listed here. There's no concept of rights listed here. Rights are implied by group membership. So if you list the groups associated with a logon name, and I have to get on to explaining why they keep saying logon and network logon. Enough information to break it down into these categories. No, forgetting about what the meaning of these categories are. We can see that rights are things that are not privileges, but determinable by group association with one of these accounts. Okay, there are accounts. Okay, let me just try to turn this into English. Now, first off, the first thing I want to mention is that I think, and I'm going to get rid of all this noise, this here screen, or the view that you're seeing here, is a screen, and there is a computer that is doing stuff, manipulating ones and zeros, and producing this image on this device. Okay? That's the most basic way to describe what this is. Everything else is a total and absolute fabrication. It's all lies. There is nothing but lies. Nothing, absolutely nothing here is real. Even you may not know this, this is supposed to be, according to the, I even have a program which prints it out. According to the, is it? According to this program, which is supposed to query the processors, and tell me what I've got. Okay, it says it's an Intel Pentium, caches, main board, Intel Aspire. Now, what does it say about the instruction set? Doesn't really say, does it? Instructions, and supports these instructions. So that I think we're meant to understand that this is an Intel chip, and therefore it is running an Intel instruction set. The instruction set is Intel, right? It's got to be. It's Intel. But in fact, that's not true. And that hasn't been true for a long time. In fact, the CPU itself is a virtual x86 processor. That is, it's not running an Intel instruction set in the end. There are two processors on this machine, and it's using pipelining for its instruction decoding, interpreting, or whatever. Now, the reason why pipelining is great is because it speeds things up. Although you can't make an instruction run any faster, but you can do you can process many instructions at the same time. So maybe you can't do one instruction in 10 clock cycles, but you could do 10 instructions in 10 clock cycles if each one takes 10 cycles to complete, and therefore on average you're getting one instruction per cycle, and that's the advantage of a pipeline. Now, pipelines are only possible when you're using what's called a RISC processor, that is a reduced instruction set processor, where all of the instructions are of the same size. Otherwise, you can't have a pipeline. The pipeline, if you've ever seen a picture of one, you might have some of my favorites. Here you go. Here's a picture of an instruction pipeline, and it works here's the pipeline, okay, for a four-stage decoder, right? Now, I always find these difficult to understand, but try to imagine. Time is this way, okay, and this is showing us what the condition is of these four instructions at any given time. Okay. Now there's other stuff going on, but we're only examining these four. Now, when all the instructions are made up of only four, are only four, let's say 4 bytes long, 4 opcodes, let's say, then you can have then a four-stage size pipeline could be used to do them simultaneously. So in this model, the first pipeline stage is a thing that fetches. The second thing is a thing that decodes. The third stage is a thing that executes, and the fourth stage is a thing that writes something somewhere. Now at time 0, nothing's happening yet. So there are 4 separate instructions, okay, being executed. Okay, now at clock cycle 1, the first instruction has been fetched, and the other 3 aren't doing anything. At time 2, the first instruction is in the process of being decoded, while the second instruction is being fetched. At step 3, the first instruction is being executed, the second instruction is being decoded, and the third instruction is being fetched. And then on the next cycle, the first instruction is doing write back, if there's any writing back to be done. But all instructions will have a write back part, even if it doesn't do anything. The third instruction is being executed, the second instruction is being the third instruction is being decoded, and the fourth instruction is being fetched. At cycle 5, first instruction has been completed. The second instruction is in the write back phase, the third is being executed, and the fourth is being decoded, and so on and so forth. Okay? So that's a pipeline. And that pipeline only works, of course, if all of the instructions can be written in this form. If the instructions were of different lengths, you couldn't do this, because you wouldn't be able to sort it out this way. Now it goes on to tell you about sometimes you can get a bubble, like if something has to wait. It's sometimes a wait state is introduced, and that'll slow things down, and that's indicated visually here. This one's not allowed to go to the decode phase yet because it has to wait for this one it has to wait for one of them to write back, I suppose. Something like that. or it has to wait for something. Let's see, who's waiting here? This one's being executed. This has to complete executing before this can get decoded, I guess. Anyway, you can get the idea vaguely, right? Well, so now an Intel instruction set, as you probably know, if you saw the DOS bit of this series, all of the instructions are different lengths, and although Intel and everybody wanted to switch to what they call a RISC architecture, all software based on an Intel instruction set, pretty much everything in the world. And so Intel stuck with their instruction set and let the engineers worry about making it go fast. And engineers are a peculiar brand of person. They seem to find a solution for everything, and the solution they came up with is that it's a fake. Okay, the instructions are written out in the format of an Intel instruction set. And then they're converted into what are called micro hops. Okay, I used to have a program same as that CPU ID, and I pulled out some of these descriptions because just the symbol micro op appears in some of these descriptions, and there are caches of these micro ops. Now, a micro op, a little operation, is a part of an Intel instruction which has been converted into a RISC type instruction to be passed on to the real processor, which doesn't know anything about Intel instruction sets, but is a pipelined processor that uses what they call deep pipelining. They have, I think the pipelines are like 8 or 16 phase pipelines for the long instructions. Instructions are quite long. And one of the process, especially with these dual processors, one processor, I think anyway, is devoted entirely to the task of executing these micro ops, executing the actual instructions, while the other is involved in fetching them and decoding them, converting the Intel instruction set into another type of instruction that can be executed by the other processor, and all of this is being done in parallel, and so the speed of a processor can be doubled, quadrupled, or whatever, not by increasing the speed of the clock or the speed of execution, but by adding more processors, just packing them one on top of the other. So the processors are fake. This is a fake. It looks as though I'm, this is my computer, and I'm, and there's an operating system, and just like DOS or whatever, it's doing things that I ask it to do. in an environment where there is input and output and instruction sets and programs and so on and so forth. But that's not the model that I don't think that this is based on. It really does look as though that the model is the corporate model I mentioned before and the office network. You'll notice, I'm going to run that program again. One of the groups mentioned in my process token is called this organization. Okay? Now, I don't know if they're just trying to make a joke here or whatever, or they just decided, why change the name for a personal computer. And I believe that this is just a fake organization that's made up in order that the NT server and office environment network situation can be mimicked, and therefore all of that comes with that can be applied to a personal computer to implement this, not only the security thing, but a lot of other useful things that they've designed for the office environment. So they make up a fictitious organization and fictitious groups and fictitious administrators. I shouldn't call them fictitious, I should call them abstract. So there's an abstraction, there's an abstract organization, there's an abstract there's an abstraction of like a set of bosses, the people who administer at least the network. Okay, these are network administrators, not necessarily the bosses, I guess. They have they maintain the server and the network environment. There's also a group of Logon console logons. That is, like a terminal logon. Is one of the employees is on the road and logged into the network through a terminal service. That's what terminal services is basically. They fall into a category. There's local. Those are the people actually sitting in the office, I guess. Now I'm not sure what this one is. Would be. I don't know what the analogy for this is, or this. I can sort of think of what that might be. And users. Okay, now I'm not sure about what all of them mean, but the analogy of the office seems to hold, at least as far as the groups go. And when you log on to your system, okay, you remember I was confused that it says Terminal Services Client Session 1. Well, I think I understand that, and you can see it actually in Process Explorer. What happens is there's a thing called okay, there are two sessions involved here, okay? Terminal sessions. Now this has no session number or identifier, okay? That is, this is not logged on to the network. Now this here is a console in a supposedly fictitious outside place, you know, not in the office, which logs onto the fictitious network that is the local computer, and that's when that's done through this thing here, this CRSS. Manages a terminal logon to the fictitious network, and these are the fictitious terminals that have logged on to the network. So that's a remote logon to an abstract network belonging to an abstract fictitious organization called this organization, and then everything follows from there. In fact, all of the sessions here are in the session 1 category, and basically all of these things, programs or whatever, are abstractions of programs running on a remote machine and having their data being transmitted back through the terminal services part of the network. I have a picture of that. This is, no, see, when they describe the terminal services, they don't even talk about actual PC personal computers. They're just simply talking about a network. CRSS, by the way, is client server runtime subsystem. So there's a client and there's a server. So now now they have what they have is something called system space and session space. Terminal server sends keyboard and mouse messages over to the CSRSS client server subsystem, which then figures out what to send back to the terminal, so that the terminal can see what their actions have done on the remote network. And actually the text is written that way. And I wrote down the text. Now here they're just talking about a real network, okay, where everyone's got a terminal, and the terminal is just a dumb terminal that's connected to a network, which is the network of the organization. And the way that they connect to that network is through terminal services. Now, terminal services transmits user interface of a program that is being run remotely by the client. With the client computer connecting through the network, sending keystroke and mouse movement information over the remote desktop protocol, RDP, okay, to the terminal server. So that's what's happening right now. Okay, I'm moving my mouse around, and that is being sent to the terminal server through RDP, and then terminal server is sending back to me, the client, screen information in the form of bandwidth-friendly, thank goodness, GDI events, and sometimes having bitmap information to properly display the desktop state were I really in the office. Okay? But of course I'm not really in the office. I'm connected through the network by terminal logon, session 1, turns out. Each user logs on and sees their individual session. Now, so that's the what they mean by I think what is meant by these session tokens and whatnot. You know, when they talk about a session, they're talking about a session with the server. Okay, and that's managed transparently by the server operating system and is independent of any other client session. So other clients being connected to this same server that doesn't exist are transparently see only their own session. The terminal server provides virtual Windows session management, so users can easily treat that session as their own personal computer. See? Even if it is their own personal computer. So I kind of summarized this here. I've probably used a lot of time. I have used a lot of time. And there's much more that I've found out. But I think you can sort of put it this way. So there is no system administrator, right, for this imaginary organization. I'm not personally an administrator of any organization, or the network, I should say. Organization's network. That my imaginary terminal is imaginatively logged on to, virtually logged on to. There's a structure called administrators, and there are administrator abstractions that belong to that structure. One of those abstractions is labeled Alan, in my case, and that abstraction exists in at least, there's more than one. One of the organization abstractions in the domain abstraction set. In the abstract domain, there's an abstract domain. There's no real domain. There's no network, so the domain's abstract. In the abstract domains of abstract administrators. Now, there's another abstraction, also labeled Alan, having the same identifier number, but is not an one of those abstract administrators in the abstract organization, but is still a member of the abstract organization. That's this Alan here that is hardly any privileges. Now there's another abstraction called Alan, which is, it turns out, an abstract administrator. For instance, if I run this, come on, there we go. Now this here, if I run that same program, you'll notice that the what was it called? Token? Okay, this is the default DACL. This, whatever this structure is, okay, is a member of administrators, okay? So this Alan abstraction is a system administrator for this abstract network. And look at all the privileges this one's got. 23, in fact. Same primary group, owned by built-in administrators, same logon session ID, same everything, source name, all that's the same. And where's my SID? Isn't it listed in there somewhere? It turns out that this one has the same security identifier, but I don't have it printed out. Okay. Now, the name of this construction is the same name as this construction. See? Only one is an administrator and the other is an employee. Both are logged on to the network, the imaginary network, through that imaginary terminal logon. Now you didn't see it, but it doesn't get recorded for some reason on the recorder. But in order for the human Alan, the person that's speaking to you right now, to allow that box to appear, I had to okay it. I had to answer a question. Do you wish to allow this? Do you, Alan, another Alan, will you allow this program to run with all these elevated privileges? And I had to click yes, or else it wouldn't have allowed. Okay. Now that granting came from the same administrator abstraction Alan as the one. Well, that granting was given by me, the real Alan, which is represented on the machine as the abstract administrator Alan, and granted the access. Now, so who was it that was being granted the access? That access was being granted to the other Alan that exists in the same organization, but is of a lower priority, and became an administrator. It acquired all of the rights that I have, as you saw, because it became an administrator. It became a member of the administrator group, which one of the versions of Alan is. At that point, there would be no distinguishing between me, Alan, the Alan that clicks buttons on the desktop, or whatever the construction that allows clicking through terminal services of things on the desktop, and the Alan that is the owner of the process that you saw running. And yet we still have these two Allens, and they still have the same identifiers, and they're somehow distinguishable. The only way that they could possibly be distinguishable, since their security identifiers are the same, and they have different rights and privileges that I can think of, is that, well, obviously they're not in this, whatever this security context thing is. It must be, I don't know if you noticed, but the organization was the same. Okay, now that would be one way you could do it. Like, you could invent a second organization, and that would allow these two fakes to exist on the same machine. But it's the same organization, okay? And it's not this. Everything else is, as far as the groups go, is the same, except one is in the administrators group and one is not. They're both in the Logon, console Logon session. They both have the same Logon IP. Right? Well, this ID won't, I don't think, it'd be the same, because that just has to do with the running of that, the remote execution of that program is a kind of transaction or session in itself. Tokens, source, user third. This part's the same. No. Okay, everything else. Yeah, I wouldn't expect these to be the same. Now, what I'm thinking is that somehow or other, there must be another fake domain that exists in this in the fake world that we've imagined, that they've imagined for themselves here, in order to make these two things distinguishable, and be able to exist on the same computer. That is, everything has to be identifiable and different. And I can't think of any. I might be wrong. There might be another way, but I can't think of any other way in which you can have two things which are identical in every single respect, ID numbers and so on, and yet not be members of the same subgroups in the same organization on the same network. So they must be on a different network. So a different fake of a network, a different abstract network. So there must be a fake domain created to allow for the existence of the employee version of Alan to exist. Now I don't know. It may not have a name. It might not be a named domain. Maybe there's a standard internal name that they use, but clearly, it's not. Whatever the thing is, the construct is in here that's doing these things on the same machine and on the same network and on everything exactly the same. Can't be the same as the other one, or else it would have the same network privileges, right? All these privileges come from the network, from the administrators. The administrators are network administrators, and this is an organization, right? And it's the same organization, so it has to be a different network, right? I can't think of any other way, right? That you could have them be different. That's one part. That's just part A of the things that I've run into in the last day, and I'll go on to part B next video. See ya.